If you build software, you get it. Making something that works right now is one thing, but building something that's still easy to change, to maintain, and to scale 6 months or a year from now, yeah, that's the real trick, isn't it? So today, we're going to open up the Architect's Toolkit and look at 5 absolutely essential principles that help you do just that: build software that lasts. Okay, let's just dive right in. We are talking about the solid principles. And I'm telling you, mastering these 5 core ideas is going to completely change the way you think about code. It's the difference between just getting things to work and actually engineering elegant solutions that stand the test of time. All right, so here's the game plan. We're going to unpack this whole toolkit piece by piece. We'll start with the S for single responsibility, then O for open closed, and we'll just work our way right through L, I, and D. Let's get to it. First up is S, the single responsibility principle. And the idea behind it? It's super simple, but oh so powerful. It's all about focus. Just do one thing, and do that one thing really, really well. So the official definition says a class should have only one reason to change. Now, what does that really mean? Well, think about it like this. If you have one class that acts like a Swiss Army knife, it handles user data, it processes payments, and it sends emails, a tiny change to how emails are sent could accidentally break the payment processing. That's a nightmare. This principle forces you to create specialists, like a surgeon's scalpel, instead of a multi-tool, making your code so much safer to work with. And this right here is a perfect picture of that idea. On the left, you've got this classic messy monolith. Everything's tangled together: payments, orders, inventory, all in one big box. The danger? A bug in the inventory code could bring your entire checkout process down. Yikes. But look at the solution on the right. See how clean that is? We have focused microservices. Each one has a single job. Now you can update your inventory system with confidence, knowing you won't break anything else. All right, on to the next tool in our kit. O, the open/closed principle. The whole goal here is to design our code so we can add cool new features without ever having to crack open and mess with the code that's already working perfectly. So what does that actually mean, open for extension but closed for modification? Well, closed for modification means that core, battle-tested code is locked down. Don't touch it. You know it works, so leave it alone. But open for extension means you've built it in a clever way so you can easily add new functionality around that stable core. This is just a brilliant example. See that core payment processor in step 1? Notice the little lock icon? It's closed. We're not changing it. Instead, in step 2, we create this generic payment interface. Think of it like a universal adapter or a plug socket. Now, whenever we want to add a new payment method, like Apple Pay or crypto, we just build a new class that fits that socket. The original processor never changes. It's rock solid, but we can extend it forever. Okay, our third principle, L for Liskov Substitution. Now I know, the name sounds a little academic, but the concept is actually about something really fundamental: trust. It's a rule for making sure your code does what you expect with no surprises. In plain English, it just means that any child version of a class should be able to step in for its parent at any time, and the whole program shouldn't even blink. If your code is expecting a bird, you should be able to give it a sparrow instead, and everything should still just work. No errors, no weird behavior. This is the perfect technical example. Our main application on the left only knows how to talk to a generic database connection. It has no idea if it's MySQL or PostgreSQL on the other end. And because both the MySQL and PostgreSQL implementations on the right perfectly honor that generic contract, we can swap them in and out whenever we want. And that is a massive win. You could switch your entire database or plug in a fake one for testing without changing a single line of your main app. That's powerful. Next up is I, the interface segregation principle. And this one is all about good boundaries. Basically, don't make your code carry baggage it doesn't need. It's about being lean and specific. You see, the problem this principle is trying to solve is something we call a fat interface. Imagine one giant contract with dozens and dozens of methods. If your poor little class only needs to use one of those methods, it's still forced to know about all the others. And that just leads to bloated, confusing code that's super easy to break. Think about a multifunction printer, right? It can print, it can scan, it can fax.
Instead of having one giant I-machine interface, we break it up into smaller, specific ones: I-printable, I-scannable, I-faxable. And why does that matter? Well, as it says here, a simple little photo printing app only cares about printing. It only needs to know about I-printable. It's not burdened with all the scanning and faxing stuff it's never going to use. The result is just cleaner, simpler, more understandable code.
And that brings us to the grand finale, D for the dependency inversion principle. Honestly, this one is the secret sauce for creating systems that are incredibly flexible and decoupled from one another. Okay, what in the world does that mean? It means your big picture logic, let's say your notification system, shouldn't be directly tied to the nitty-gritty details like the specific code that sends an SMS message. Instead, they should meet in the middle, at this kind of neutral agreement, an abstract contract. You're breaking that direct chain of command, which makes everything way more adaptable. This slide just nails it. Look at the problem on the left. The high-level notification manager is directly bossing around the low-level email and SMS services. If you want to add push notifications, you have to go in and change the manager. But look at the solution on the right. See how the dependencies are inverted? The manager only knows about that abstract iMessage service in the middle, and now the email and SMS services point up to it. The incredible benefit here? We can add a new push notification service tomorrow, and the high-level manager doesn't need to change at all. And that is a total game changer. So there you have it, the 5 solid principles. From the focus of single responsibility to the flexibility of dependency inversion, every single one of these is a critical tool for your belt. They're the foundation of software that's a joy to work on, not a pain. So I'll leave you with this one question. Looking at the code you're working on right now, which one of these principles could you use tomorrow to make a real difference?